Observational study versus design experiments. Let's review. In the last section, we learned about observational studies and design experiments. Observational studies, the researchers just observe. Design experiments, there is a control group and a treatment group. The treatment group, the explanatory variable is changed and the response variable is recorded. And we talked about three variables: the explanatory variable, the input, the x variable. The response variable is like the output or the y variable, and the lurking variable is a variable that can affect both. So it can sort of cloud the relationship between the explanatory and the response. Let's look at some examples involving lurking variables. A study stated the following: pregnant women who eat lobster have healthier new babies. And the explanatory variable is if the pregnant female ate lobster or didn't. The response variable is how healthy the new baby is. So, does eating lobster really cause healthier babies? I don't think so. I think there's a lurking variable. The lurking variable would be money. Pregnant women who eat lobster means that they can probably afford lobster. And if they can afford lobster, if they are sick or need to go to the doctor, they can do so. Pregnant women who do not eat lobster may not have the money if they are sick or need to see the doctor. And this may explain the relationship between eating lobster and healthier babies. Let's look at another example. Suppose there was a study that involved firefighters and loss of personal property. After careful review of fire records, the researcher concluded there's an association between firefighters and property damage. Does this mean that you shouldn't call the fire department, or is there some kind of lurking variable? The lurking variable probably is the fire. The fire is causing both the damage and the firefighters being there to fight the fire. Let's look at a third example. There is an association between the number of ice cream cones sold at the beach and the number of drownings. As the ice cream cone goes up, the number of drowning goes up. So, is it the ice cream cones that's causing the drowning, or is there a lurking variable? One possible lurking variable would be temperature. As the temperature goes up, more people go to the beach. As more people go to the beach, they buy more ice cream cones. And if there's more people at the beach, there's going to be more people in the water. More people in the water means there's a higher probability of having a drowning. So I think in this example, the lurking variable is temperature. Let's look at some more examples. Suppose that you study children at an elementary school. You recorded the shoe size and measured their reading ability. You analyze this data and see that those with longer feet tend to read better. The explanatory variable would be the shoe size. The response variable would be reading ability. Next question: is this an observational study or a design experiment? For this to be an experiment, you have to be able to change the explanatory variable. You can't really control shoe size, and you're also just observing the relationship between these two. This is an observational study. Part C. Can you conclude from this study that having longer feet causes a child to read better? If not, suggest a lurking variable whose effects on the response are confounded with those of the explanatory. Because this is an observational study, we only are observing, and a possible lurking variable would be age. As a student is older, their feet grow, and as their feet grow, their reading ability increases also. Next example. In this study, researchers reported that people who tend to think positive thoughts catch a cold less often than those who tend to think negative thoughts. They recruited 300 healthy volunteers and interviewed them over 2 weeks to gauge their emotional state, and eventually assigning them a numerical score for their positive emotions. Then the researcher injected rhinovirus, a germ that causes cold, into each subject's nose. The subjects were then monitored for the development of cold-like symptoms. Subjects scoring in the bottom third for positive emotions were 3 times more likely to catch a cold than those scoring in the top 1/3. Okay, Part A. Identify the explanatory and response variable. The explanatory variable would be the numerical score for the positive emotions. The response variable would be the duration of the cold. The response variable would be if they catch a cold or not. B. Is this an observational study or an experiment? And to answer this question, we need to think, are we controlling the explanatory variable? Are we changing it? And the answer is no. Everybody got injected with the rhinovirus. There was not a control group or a treatment group. Everybody got the same germ. And then we just observed. So this is an observational study. Part C, can we draw cause and effect conclusions between emotional outlook and the likelihood of catching a cold based on this study? The answer is no. We can only draw cause and effect conclusions from design experiments, and this is an observational study. Last example, to study the effectiveness of a zinc nasal spray for reducing the duration of a common cold, researchers recruited 104 subjects who agreed to report to the lab within 24 hours of getting cold symptoms. Each subject was randomly assigned to one of three groups. One group received a full dosage of the zinc spray, another received a lower dosage, and the third received a placebo spray. The placebo spray is a spray that has no medication in it. The cold symptoms last an average of 1.5 days for the full dose group, 3.5 for the lower dose group, and 10 days for the placebo group. So Part A, identify the explanatory and response variable. The explanatory variable would be the amount of zinc spray. The response would be the duration of the cold. Is this an observational study or an experiment? And to answer that, are we controlling the explanatory variable? And the answer is yes. We have three groups. The first group gets the largest dose, the second group gets a smaller dose, and the third gets no dose. So we have a treatment group and we have a control group. This is an experiment. Part C, do you think the researchers use a placebo spray as opposed to just providing no treatment for that group of subjects? We want the group getting the placebo to actually think that they're getting medication, because the power of suggestion does play a role when dealing with humans. Thanks for watching.